Welcome to our review of modeling. We're going to conclude our lesson with an excellent 2 review sets on the last 4 pieces of the modeling we went over. We're going to understand the modeling cycle, those are A, create and read basic linear models, or B, our C, which was reading and creating linear piecewise models, and then finally what we did last time, using systems of equations to create and solve models based on graphs and systems of equations. So, without further ado, it's in page 89 to 93 in your book, but let's go. Number 1, all examples, no learning. Ben loves to kayak. He could paddle 100 meters in 40 seconds. Construct a model, see how far he can kayak in 2 seconds. All right, go. Okay, you done? We know that distance over time, give you another second in case you messed that up, pause it, is 100 meters over 40 seconds. How far can you paddle in T seconds? So we're going to put T seconds on bottom and X meters on top, or D meters on top. And it doesn't matter really what letters you use. T you always use for time. This could be D for distance, X just really like X. All right, so what do you do here? You cross multiply. All right, I pretty much cancel out the meters words and the second words because they're on top and top, and just keep my numbers. And then once I do that, I'm going to go, okay, let me cross multiply here. D times 40 equals T times 100, or 100 times T equals 40 times D. Doesn't really matter. We're solving here for how far. So we're solving for D. So we're going to divide both sides by 40. You divide by whatever is next to the D. When you do that, you get D equals 100T divided by 40. All right? And that's it. That is our model. Does that look familiar? It's just like the one we did a couple weeks ago. Next, now, predict how far you can paddle in 10 minutes. Now, here's the key. This model is for seconds. We want to do minutes. So how many seconds is 10 minutes? Well, there's 60 seconds in the middle. Oh, sorry. Jumped ahead and never reduced this. Divide this by 20 over 20. D equals 5 over 2 T meters. If you don't reduce it, will your answer technically be wrong? No, but it won't be great. 10 minutes. D equals 5 over 2T. 10 minutes, like I said, is 600 seconds. 5 over 2 times 600 is 3,000 divided by 2, 1,500 meters. All right, now, the way this works, pretty easy. All right, if you left this as 140, this would just be 100 times 600, which is 60,000 divided by 40, which also equals 1,500. So you still get the same answer. Do you think this is the actual distance he can paddle in 10 minutes? Explain it. I want you to explain it. Think he actually paddles that far? Answer should be no, right? He's going to probably paddle less. Why do you think he paddles less? Come on, tell me. The reason he paddles less is, what do you think? Why? Because he gets tired. You can't paddle for 10 minutes at the same speed that you paddle for 40 seconds. The longer you paddle, the less speed you go. Okay? It's like a sprinter can't run a mile at the same pace they run 400 meters or even 100 meters. Okay? Common sense. Problem number, you get tired. Number 2, some water is boiled. Oh, we did something like this before. And then after you boil it, you pour it into a cup. Maybe you're making coffee. That's how I make my coffee. Instant coffee. Can't beat it. Nice. Costs about 5 cents a cup. Which of these graphs do you think is the most appropriate model for the temperature of water? Okay? So, you boil the water, it gets really hot, and then you just dump it in the cup. So which one of these models do you think represents that? You should have said model A. Why? Well, why? Why would you select that? Well, look at this one. It doesn't go down exactly the same thing. When, and it also doesn't get hot slow. So when you initially pour this boiling water into a cup, you're not heating it, you're not boiling it anymore. So the temperature drops really rapidly. And then after it drops rapidly, it stays the same temperature for a while. Okay? Boiled water boils at 100 degrees. As soon as you stop boiling it, it drops down pretty quickly, and then it maintains temperature. This, it wouldn't go down straight like that linear, no. And it wouldn't go down gradual, and then just take a really quick jump down there and get really cold. Okay? Also, why would your water go to negative degrees? It wouldn't. It'd be frozen. Why would your water just freeze out of nowhere? Unless you're on the North Pole, which you're not. Predict the water after 10 minutes. So I have to use this model. So after 10 minutes, I'll go up here, make my point. It would be about 40 degrees Celsius. If I was using this model, 10 minutes, it'd be 50. If I was using this model, it'd be 90. So if you poured boiling water out after 10 minutes, do you think it'd still be 90 degrees? No, of course not. Right? If you poured it out here, would it still be 50? Well, then maybe. But like again, you really don't have linear curves in real life. Problem 3, the amount of oil left in a leaky barrel. All right, after T minutes is shown in the graph. Find the gradient and the A-intercept of the line, and then you're going to interpret your answers. So first thing we're going to do is find the gradient. Another word for gradient is, we went over this, slope. So we're going to pick 2 points on this line. First thing, I'll find the A-intercept. That's the 1.0160. And then I'm going to pick a point where it meets again. I'd probably pick this point right here. Of course I did. I like to pick where they meet perfectly, so it's nice and clean. So that's 140. Gradient. Formula for slope is y2 minus y1 over x2 minus x1. I made this mistake in the other one too, and I missed them both. Remember that? I made this a while ago. 3a. So, what you do is, this is my y1, this is my y2, 140 minus 160, this is my x2, 4 minus 0. 20 divided by 4, negative 20 divided by 4, reduces to negative 5. Right? My A-intercept, where does it intercept the axis? Right there. The gradient is negative 5, A-intercept is 160. Technically, it's the y-intercept, but it's not the y-axis, it's the a-axis. Can we find a model connecting the two? Yeah. This is a straight line, so y equals mx plus b, right? Your b is 160. Your slope is negative 5, so y equals mx plus b, or a equals mt plus b. So a is, we don't know, m is negative 5, t plus 160. The key is you want to switch these, because this is the same formula, y equals mx plus b. But look at our x-axis has a t, and our y-axis has a t. How much oil will be left after 15 minutes? Let me look at my graph. Oh, uh-oh. 15 minutes is there. So we're going to have to use our equation. We used our graph to create a model. We're using our model to predict something. And that's how math works. So you're going to take your 15, you're going to plug it in for your t. 5 times negative 15 is negative 75. 160 minus 75 is 85 liters. So there will be 85 liters of oil left after 15 minutes. Question D. What value of t is reasonable to apply this model? So between 0 and what? Well, until it runs out, right? So when does this run out? When what equals what? Well, when A equals 0, there's no more oil. You can't have negative oil, can you? No. So you just set this equation equal to 0. 0 equals negative 5t plus 160. Subtract the 160, divide by a negative 5, and you get t equals 32 minutes. All right, so that means from what to what can we apply this model? What are our parameters? From 0 minutes, t could be greater than or equal to 0 minutes, because we know at 0 minutes we're full, and less than or equal to 32 minutes, because we know at 32 minutes we're at 0. 1 second after 32, no good, because then we're at negative. Same. All right? Let's move on to problem number. Plumber charges 50 pounds for a call outfit. All right, and then 80 pounds for each hour he spends on the job. Complete the table. All right, way to complete this table. Call out fee means he pays $50 just to go out. and then he pays $80. So you're going to take this number, you're going to add 80, 130, add 80, 210, add 80, 290, 370. Draw a graph. Now this is your X, this is your Y. So when you draw a graph, C against T, you're going to go over 0, up 50, put a point. Over 1, up 130, put a point. Over 2, up 210, put a point. Over 3, up 290, put a point. Over 4, up 370, put a point. Now, do you think this makes a straight line? Perfectly straight. That's a good linear model. So now we can actually create the linear model. I want to know numbers. I don't want to just know a picture. I want to be able to take this number, make an equation from it, and then predict what it's going to be after 6 hours. So we need to know the gradient, and we need to know the C-intercept. First thing we can do is find the intercept. The intercept is y equals mx plus b, your call-out fee. How much was the call-out fee? $50. That was your initial amount, 50, 0. What's our gradient? Rise over run. Well, it tells us every hour it's $80, 80 pounds. So that's 50. So y equals 80x plus 50. That's it. Find the cost of a job that takes 6 hours. This time's in days. Is that time in days? Or is that time supposed to be in hours? Uh-oh, I could have messed this whole problem up. Well, C equals 80. Nope, this should say hours. Ha. Fixed. Hence, find the cost of a job that takes 6 hours. So, 80 times 6 plus 50. And then what you have is 480 plus 50 is 530. Okay. That's how much it costs. 530 pounds. Amy and Bernard, both electricians. It would take each of them 3 days to wire a particular house. Assuming they're able to work without getting in each other's way. So now they're not going to get in each other's way. How long do you think it would take the two of them to do a job? All right. This is a little tricky. So, we're working together, right? Amy can wire how much of the house each day? What do you think? Well, it takes her 3 days. So how much of one house could she do in 1 day? Reciprocate 3, 1/3. All right, Bernard, you can also do it in 3 days. So how long can you do one house in? How much of a house can you do in a day? Reciprocal of 3, which is 1/3. All right, so how long will it take both of them to do the job? What do we do? How long would it take both of them? How much of a house, sorry, can both of them wire a day? 1/3 plus 1/3 equals 1/6 of a 2/3 of a house per day. Where do I get 1/6 from? So they could do 2/3 of a house per day. So how long would it take the two of them to do a whole job? Right? How long? How long would it take the two of them to wire a house? If together they do 2/3 a house per day, how do you find out how long it takes? You take that number and you reciprocate it. It would take them 3/2 of a day, or 1.5 days. Do you think this is reasonable? Yeah, no, it's not reasonable. The job would probably take more time than the prediction. Okay? You wouldn't just say divide this number by 2. It probably, I think it's reasonable. I don't know why they don't like to be reasonable. It would take a little more time just because there's more difficult things to do in wiring houses and other types of, someone has to do the difficult job, you have to call people to help you out and things like that. But that's getting really technical. I don't know why this book's going there. I personally think it's pretty reasonable, but technically it's not. It would take a little bit more time. All right, problem 6. This graph shows the cost of hiring a squash court. Squash court's a game, it's a It's a weird game. I don't even know how to explain. I was going to make something up, but I don't want to insult your intelligence. Find the cost of hiring the court for 45 minutes or 2 hours. So you're reading a piecewise equation here. Kate and Peggy can spend no more than $15 each to hire a court. What's the longest they do it for? So first thing, we're going to go 45 minutes. So this is 0 minutes. This is 1 hour. This is 30 minutes. So 45 minutes is between 30 minutes and an hour. And that would cost right there, which would be $25. All right, 2 hours. You go over to 2 hours. You go up to see where you hit. Now, even though it hit both of these, this is where the closed circle is. So this is the one that counts. And that you move over, that's $35. Now, if they can each spend no more than $15 each to hire a court, the longest they can wear the coat for. So since they each spend $15, how much money do they have? They got 30 bucks. All right, so they have $30. How long can they get the court for? Well, they can't get the court for this long or this long because that's more than 30, that's 35. They would have to go down here. All right, now the longest amount here is they can rent it from anywhere from a half hour to an hour. So the longest they can rent it for is 1 hour. Right? Next problem. A triathlon consists of a 1.5 kilometer swim, a 40-kilometer bike ride, a 10-kilometer run, and the table shows the times obtained for each one. Now, what you're trying to figure out how to do is you want to know the distance graph. So the first thing you're going to do is you're going to graph these things on this graph. So when you draw the distance time graph in the model and you're drawing her position, what are you doing first? Let's do swim. 36 minutes, first leg. How far does she swim? 1.5 kilometers. So 36 minutes over, 1.5 kilometers up. So her time is 36, her distance is 1.5. So that's pretty small right there, but it's still not too terrible. All right? Next thing. You have bicycle ride, 117. All right, 117 minutes you're going, but he goes 40 kilometers. Now he goes a lot. So what you do is you actually take, sorry, not 117. Take your 81, add it to 36. So the total time now is 117. 40 plus 1.5, your total time is 41.5. So you're going 41.5 up, and you go 117 over, and then that's your line. You have to keep on adding these pieces together. Next thing you're doing, you're running. 171, why is time? Because you're adding 54 to 117, you get 71. You're going to add 10 to your 41.5, you get 51.5. So you're going to go over 171, up 51.5, and there is the continuation of your graph. All right? Almost there, we're doing good. Next section. Describe any assumptions that you made when constructing the graph. Now, the assumptions you guys probably made were that they travel at a constant rate of speed. All right? So they're traveling at a constant rate of speed. That's a pretty good assumption. Probably true. Typically, though, you don't travel at a constant rate of speed, though, because you go up hills, you go down hills, you go on flat land. So you can go at different speeds during it, but pretty much the beginning and end will be the same. Use your graph to estimate how far they traveled after 1 hour. 1 hour is 60 minutes, so you go up here, you go to the right, and you can estimate that it's about 13 kilometers. All right? It's a little bit between half of the way of half between 10 and 20. All right. Next problem, you're going to use your calculator here. This is the systems of equations. All right, and using the calculator, you have two equations with two variables. So your first one, you're going to plug into your regular equation, ax plus b over x. So you plug in your answer. You get 7 equals a plus b. That's 1. Number 2. You're going to plug in 8 equals 2x plus b over 2. That becomes 2a plus 1/2 b. All right. And then you put in your systems of equations. 1 plus 1 equals 7. 2 plus 1/2 equals 8. Type of your question, y equals 3x plus 4 over x. Okay. Next one, 1 equals a1 cubed plus b1 squared plus c1. These are all just a plus b plus c. 6 equals a2 cubed plus 2b squared, b2 squared plus c2. 8a, 4b, 2c. And then 27 equals 3 cubed a, 3 squared b, 3c. 27a plus 9b plus 3c. Okay. Nice and easy. Plug it into your equation. Once you plug it into your equation, you solve. And when solving, you get as an answer 2x squared minus 2x cubed minus 4x squared plus 3x. Problem 9. Way you do this problem, fairly simple. The graph shows the relationship between speed of Daniel's car and the braking distance. What you need to know is what distance is required for the car to come to a complete stop. So you're going to use a system of equations right here to solve for the equation. So once again, you're plugging in your y and your x into your problem. Upon doing so, you get 19 equals a10 squared plus b times 10. 19 equals 100a plus 10b. All right, 19 equals, that's your first equation. Then you're going to do 52 equals 20 squared plus 20 times b. 52 equals 400a plus 20b. You have two equations and you have two unknowns. You plug them in. 110, 19, 420, 52. Spits out your equation where a is 7 over 100 and b is 6 over 5. All right. Use this model to predict the braking distance when it's traveling 30 meters per second. So you create your model. Your model is going to be y equals 7 over 100 x squared plus 6 over 5x. Now you want to find out traveling this far, so that's a speed, so that's your x that you're plugging in. You're plugging in 30 into there. 7 over 10 times 30 squared plus 6 over 5 times 30. You get 99 meters. Can we use this model to predict the braking distance for a different person? What do you think? You actually cannot. The reason for that is braking distance is pretty much dependent on the driver's reaction time and the driver's speed. All right, and the type of car. Different cars brake at different rates. All right, next problem. Back to the originals. Unit and go. All right, so first one, you got to state any assumptions. You got Todd and you got Sophie. They both meet. You're going to do the inverses of both of them. So, fairly simple. Todd can read 1 over 3. The inverse of 3 is 1/3. Sophie, 1 over 3.5. Now, 1 over 3.5 is not really good. So you want to multiply this by 2 over 2 to get whole numbers here, which is 2 over 7. So Sophie can technically read 2 over 7 of the garden per hour. So to find out how much they both can read together, you're going to add the fractions, 1/3 plus 2 over 7. You need a common denominator. So a common denominator of this is 21. Multiply the first one by 7 over 7. Multiply the second one by 3 over 3. 7 times 1 is 7. 7 times 3 is 21. 7 over 21. 2 times 3 is 6. 7 times 3 is 21. 6 plus 7 is 13 over 21 gardens per hour. All right, so they can pretty much about 2/3 of the garden per hour. Now to find out how long it will take them, you do another reciprocal, and it's 21 over 13 hours, or 1 in 18 over 13 hours. If you want to convert that to hours and minutes, you would do 1 hour and 8 over 13 times 60, and that would give you your minutes. All right, which is 1 hour and 37 minutes. All right. Not too hard, right? Let's go to the next one. Next one states, you got Rohan, he has a lawnmower. That lawnmower cuts his lawn to grass to a height of 17 millimeters. All right, that's pretty small. So what happens with this is, you want to know the grass grows 3 millimeters a day. So it grows a little bit. And what ends up happening then is, I want you to construct a table of values based on that info. All right, first thing you're going to do is you are going to take the 17, and that 17 right there is your, hopefully that works, y-intercept. After you take the 17, you are going to, good, add 3 meters a day. So the first day, you grow 3 meters. 17 plus 3 is 20. Then you're going to grow another 3 meters. That's 23. Then another 3 is 26. All right. Then another 3 is 29. All right. Now, find the linear model connecting these two. All right, what that means is, can I create the linear model? So I'm going to take my y-intercept, which is 17. All right? Oh, actually, B is draw the graph. So the first thing I do is I put my y-intercept down. My y-intercept is right here at 17. And then I'm going to go up and plot each one of these points. And upon plotting each one of these points, Notice they go up evenly. I draw a line straight through it. Can I find a linear model connecting these things? Of course you can. The way you would do that is very simple. You would just say B equals 17. Your initial point. All right? After you find B, you're going to find where my number's at. There we go. M, which is 3. Why is it 3? Because it grows 3 meters a day. You're going up 3 over 1 each day. All right, you're going to create your linear number. H is 3D plus 17. All right, so that's your equation. Y equals mx plus b. Your y is your h, so h equals 3, which is your gradient, d plus your intercept, which is 17. All right, find the height of the lawn after 12 days. Now we can use this and plug 12 in for our 3. All right, when we plug 12 in for our 3, what we're going to do is, what do we get? 3 times 12 plus 17. 3 times 12 is 36. So you get the height equals 36 plus 17. And 36 plus 17 ends up equaling 53 millimeters. All right, so after 12 days, if you don't cut the lawn, it gets to be 53 millimeters. All right? Now Rohan, what he does next is he mows the lawn again when it's 8 centimeters high. How often does he mow the lawn? When it's 8 centimeters high, centimeter is how many meters? A centimeter is 10 millimeters. So that means 8 centimeters is 80 millimeters. So when this thing is 80 millimeters, which is off our graph, how many long is that going to be? That's going to be longer than 14 days. So what we can do is take our 80 and just replace our h with our 80 and then solve for t. So what we do here is 80 equals 3d plus 17. All right. Subtract 17 from both sides. After you subtract 17 from both sides, what you end up getting is 3d equals 63. Divide both sides here by 3. All right. You get 21. So after 21 days, you would have to cut this on. All right. That's not too terrible, is it? All right, let's go to problem number 3. Oops. All right, so Elizabeth needs to estimate the volume of usable wood in the trees growing on a plantation. She measures a sample of trees and finds the average trunk width is 45 centimeters. Her calculation, she assumes that the trees are perfectly cylindrical and that 80% of the wood, all right, in each tree is usable. Do you think these assumptions are reasonable? So do you think these are decent assumptions, or do you think they're kind of crummy assumptions? So the first thing you have to do here is, yes, I think they're reasonable. Now explain why. Well, the reason is not all the wood in a tree is usable. What parts of a tree are not usable? Do you guys know? Well, the part of a tree that's not usable, what about the branches? Are you going to make tables out of branches? No, you might be able to grind them up and turn them into pulp and make paper out of them. Trees are basically cylindrical, because you basically have your cylindrical tree. All right, and then you chop everything off the trees, and then you just keep really the big base of the tree, and that's what you use. All right, so it's a good idea. Based on these assumptions, we're going to construct a model for the volume of the usable wood in a tree that is h meters high. So what do we need to know? We need to know the formula for volume of a tree. What's the volume of a cylinder? You have to take its surface and multiply it by its height. So the surface of a cylinder is a circle, which is pi r squared times height. That's how you can find volume of a cylinder if you forget the formula. Now, what do we do next? We have our base, and we're going to take our formula, and we go, all right, we got our pi r squared. Let's see, now what should we do? We need a usable wood. Well, what does this say? Let's read. The average trunk width is 45 centimeters. Is width the radius? Width is the distance all the way across. No. So, and then it says 80% of the tree wood is usable. So we only want the volume of 80% of this, right? 80% is 80 over 100, or 0.8. So we're going to multiply this whole thing by 0.8. Now 45 centimeters, because we're dealing with meters, that should just say meters, there's too many M's there. 45 centimeters, there's 100 centimeters in a meter, so that's 0.45 meters. All right, so 3B, 45 meters. All right. Okay, so now we do that, but we know we don't want the width. Radius isn't that. Radius is, this is the width. We only want the radius, which is half the width. So we take half the diameter, half of 0.45, which is 0.225 meters. All right. Now I can plug that in here. I don't know what my H is yet, but I do know my volume of usable wood. I just put that there because it kind of looked cool. Is 0.8 times the volume times pi radius squared h. And then depending on what our h is, we'll get different answers. Multiply 0.8 times 0.225 is 0.0405 pi h. Notice I went 3 significant figures and I kept the pi in there. Keeping the pi in there makes the answer more accurate. And there's a pi button press. So now hence, what's the volume of the tree? Volume of the wood in a 15-meter high tree. Now you can just type in 15 for h. 0.045 times pi times 15, it's about 1.91 cubic meters. That's how much wood you'll get from there. If it was 20, now you can go, what about if the tree grew to 20 meters? Well, I just put a 20 in here. What if it was only 5 meters? I just put a 5 in here. So this formula tells me all those answers just from that one formula. All right? Isn't that cool? I think it's cool. Problem number 4. The graph shows the population of France. All right? In millions since the start of 2010. The linear model, P equals 0.336T plus 64.6. All right? What that does is the linear model exact or is it approximate? Well, look at those points. Are those points exactly on the line? No, so it's approximate. All right, why? The points don't lie exactly on the line. That was pretty easy. Use the model to predict when French population reaches 75 million. Well, this is 70 million, so it's going to be somewhere over there. So we're going to have to create an equation, which we already have. All right, they had this model made from this equation. They made it themselves. So, population is 75 million. So this is the population times a million. So we can just put 75 in for P. And keep the rest of the model. Subtract 64.6, divide by 336 thousandths, and you get T equals 33.9. So that means in 33.9 years, since 2010, that's what it will be. So you have to take your about 40 years from 2010. So what do? You add them together. 2010 plus your 40, 2050. All right, so you're going to add the 2010 to the 40 years, and you get your year 2050. Now, is that really reasonable for that many people to be around in France in 2050? Well, maybe, but we're going to say it's not really. You know why? Because it's an extrapolation. We don't know the final situation there. We don't know if something's going to happen to France. Maybe they get in a war where all their men go away. Maybe there's a plague that wipes out half of France. Maybe everyone decides to have babies and then the number goes up exponentially. There's all these outlying factors where 50 years away is way too far, 40 years away, way too far away to predict. So you can't really say it's a reasonable estimate. All right, nice exercise, just not really reasonable. Shane is looking for somewhere to stay during his vacation. He's choosing between the following places. Number 1 is Bob's Beach House, which costs about $150 per night for the first 2 nights, and then $120 for each additional night. Claire's Cottage is about $180 a night, all right, for the first 3 nights, and then it's $100 for each additional night. On the same set of axes, graph the cost against the number of nights for each place. All right, so let's look on the first set of axes. What we're going to do is we're going to graph Bob's Beach House first. So $150 per night for the first 2 nights. So first night, $150. Second night, $150 and $150 is $300. All right, so you got $300. Now you're going to add $100.20 to each one of those. So 300 plus 120 is 420. 540. All right, 6 660, 780, 800, 900, right? Yep, 900. How many nights do you want to do this for? And 1,020. All right, and then 1,140. So that's a pretty good one. Now we're going to do the next one. And 180 for a night for the first 3 nights. So we're going to do 180, 360, 540. And now it's only $100 every night. So 540, 640, 740, 840, 940, 1,040, 1,140. All right. So, what do you notice is happening? That's pretty interesting. So how much would it cost to stay 4 nights at Bob's Beach House? Bob's Beach House is, first 2 nights, 120, so 2 times 120, 2 times 150, plus 2 times 120. First 2 nights, second 2 nights. 300 plus 240 equals $540. What's the cost of staying 4 nights at Claire's cottage? Well, 3 times 180 plus 100. 1 night. $640. So it's a little more expensive to stay at Claire's for that one. All right, that's interesting. So so we can use math then to help us out and tell us how to save money. Maybe if you guys go to prom weekend eventually, figure out which place is cheaper when you stay there for a weekend, a week, you know that. Summer vacation, stuff like that. Shay's looking for somewhere to stay during the vacation. He's choosing between the following places. It's the same question. What length to stay? For what length is the cost the same at each place? So I can create an equation here and find it out. So after 3 days, is the length the same? Well, let's look. For what length stay is the cost the same for each place? After 3 days, right? The first 3 days, 2 times 150 plus 120 plus, that's 3 days, 120 times the rest of the days. 3 days of his house is 3 times 180, and then what you're going to do is you're going to add 100x afterwards. So what this means, and it might be a little confusing, is I showed you the first 3 days they use different formulas. This one's really 2 times 150, and then it's 120 after that. So this is the first 3 days here. First 3 days here is 3 times 180. But then, this is where it changes. Every day after that, from the 4th day on, this is 120x, the other one's 100x. So now when I do this, 300 plus 120, that's 420 plus 120, 540 plus 100. Subtract 100x from both sides, you get 20x. Subtract 420 from both sides, you get, where do you get 12 from? You get 80. All right, 80 divided by 20 is 6. Oh, 120. My math's slipping on there. Should be a math teacher, right? 5C, 120. All right, now it's just a typo. So, because I divide both sides by 20. So after 6 days, they cost the same. Now he wants to stay for 8 nights. Which place will be cheaper? Well, if it's 6 days, they cost the same. So let's look at 8 nights. 2 times 150 plus 6 times 120. 3 days plus 6 days. Oh, 9 days. So this is 6 days on top of the 3 days over here. I almost forgot that. So 6 days after our initial 3 days. All right, so up to 3 days, this is how much it costs after 3 days. This is every day after 3. All right. Shane wants to stay for 8 nights. So 2 times 150 plus 120 times 6. 300 plus 820. $1,020 for Bob's Beach House. Claire's Cottage, 3 times 180 plus 5 times 100. All right, 540 plus 500 is 1,040. So it's still cheaper to stay at Bob's Beach House by $20. But after the 8th night, 9 days are the same, and then every day after 9 days, guess what? Claire's is cheaper. So if you're going to stay there after 9 days, you're going to go to Claire's. Anything before 9, you're going to go to Bob's. All right? Why don't you guys attempt problem number 6? All right. For 2019, the income rates for a single person. Residents in Germany are shown with the graph alongside. Whoops. What type of model is this? So that's pretty easy. What type of model you got going on there? Did you say a piecewise linear model? If you did, you are correct. Good. Next one. Estimate the rate payable. Gurtjan has an annual income of 34,500 euros. So that's about 32.7%. How do I know that? I'm going to go over to it, and I'm going to extrapolate that from there. All right? I'm going to say, what is it, 3,400? So this is 20, this is 40, 34 is about here. Go up to here, go over here. This is 24. Each one of these goes up by 1, 2, 3, 4. They go up by 3, so 24, 27, 30, 33. So it's right between 30 and 33. That's where you get your 32.7. The tax payable on 55,961 is 14,029.32 euros. Calculate the income payment on Nicholas, who earns almost twice as much in 2019. So, the income tax rate is what? That's just your rate percentages. So, what does he make? So this is the tax payable on your first 55,000. If he owns 108, what you're doing is you're subtracting 55,000 from 108, and then you're multiplying that number by 42%. He gets 55, what do you got? 108,000, you're paying your 42%. So 42% of 5264 is 22,112, and don't forget to add that 14 to it, and that means you're going to be paying 36,841.48 euros. All right? Got it? Pretty easy. Problem number 7. In a show jumping competition, we're almost done. How much we got left? We got a couple left, like 3. In a show jumping competition, what happens here is a competitor is given one-time penalty for every commenced 4 seconds by which they exceed the time allowed. For example, the time allowed is 75 seconds and the competitor takes 79.4 seconds. They're 4.4 seconds over the time allowed, so they're given 2 time penalties. A, draw a graph to display the time penalties for the different times over the time allowed. So let's do the first thing. We're going to go draw our graph. Step away so you can see. And now let's draw it. So, given a one-time penalty for every 4 seconds which they are over the time allowed. So, 4 seconds, they're given a 1-point penalty. All right? For the next 4 seconds, they're given another point. So from 4 to 8, they got another point penalty. All right? They get 3-point penalties for next 4 seconds, 8 to 12. All right? Next one, from 12 to 16, 4 points. From 16 to 20, 5 points. 20 to 24, 6 points. 24 to 20, oh, didn't do that. All right? So 1 point for every 4 seconds. So if you miss it by 3 seconds, it's the same as 1 second. 3.9 seconds, the same as 1 second. All right. What kind of graph is that? Piecewise. If the time allowed is 82 seconds, so that means that this is 82 seconds. This would be everywhere from 82 to 86. 86 to 90, 90 to, and so on. So first one, 83 seconds. That's how long it took. How long are you allowed? You're only allowed 82. So 83.1 minus 82 is 1.1 seconds over. So what's our penalty? Go over to 1.1, 1 point penalty. You got it? Do the rest. All right, 8.79. Subtract 82 from it, you get 5.9. 2 point penalty. 3's the trick one. 81.5, you get negative 0.5. Wait. There's no points. Why? Because you didn't fall in the penalty area. You're actually faster than the allotted time. Last one. Oh, you're really slow there. 96 minus 82 is 14.3. 4 point penalty. Okay. Number 3. Determine the model for the graph. We're going to finish up with some modeling. So first model. 3 equals A1 plus B times square root of 1. 3 equals A plus B. 8 equals 4 times A plus the square root of 4, which is 2. 8 equals 4A plus 2B. We're going to type this into our calculator, and you get your system of equations here. And x equals 2 square root x. All right. Once again, the way you're going to do this, very simple. I'll come over here and show you because I'm so nice. You go to your calculator, you hit your apps button, you go down to number 9, hit enter. In this case, you're going to hit 2, simultaneous equation solver. There's only 2 equations and there's 2 variables. For B, there's 3 equations, 3 variables. And whatever it is you hit next, you can clear your answers right here, type in all your stuff, and you hit solve. All right, for a problem like B, you go back to the main. I'm going to hit enter, and I'm going to go 3 equations, 3 unknowns. You have to have as many equations as unknowns. Hit next, and then I type in all that stuff there, hit solve, and it spits out my answers. So upon doing this one, first you have to create your models. So it's A times 1 squared plus B times 1 plus C over 1. 12 equals A plus B plus C. We'll do 2, 10. 10 equals 2 squared, which is 4. 2 and C over 2 is 1/2 C. 6 equals 4 squared, which is 16A plus 4 times B plus 1 over 4C. All right, I type this in. 1, 1, 1, 12. 4, 2, 1/2. 1 divided by 2 equal, don't forget the equal 10. 16, 4.256. Spits out, it says negative 1, 5, 8. So my answer is negative x squared plus 5x plus 8 over x. All right, remember if you're doing subtracting signs, you can switch those as well. Problem 9. A tray is formed by cutting the squares from a corner of 30 by 30 sheet of metal and then folding the remainder. The squares are cut out of an x by x by x centimeters. The volume of the container is written on the form. Volume equals ax cubed plus bx squared plus cx plus d. Explain why d is 0. Why is d 0? Anyone? Because it's only 3 dimensions, right? If x is 0, the metal can't be folded, right? So therefore d has to be 0. Because if x is 0, you got a square. If you have a square, there's no folding places, so there is no d. All right, so you don't even need d. This is like a trick. All right, so the volume is 0, therefore there's no y-intercept. All right. Use the data to find points A, B, and C. So we've got our x and our y. We're going to plug this in. 1,352 equals A2 cubed plus B2 squared plus C2. We don't have a D, so you don't have to plug it in. 8A, 4A, 2C. 2,000 equals A5 cubed plus B5 squared plus C5. 125, 25, and 5. 1,000 equals A10 cubed plus B10 squared plus C10. 1,000A, 100B, 10C. All right, we plug in our 3 things. into our equation. 8, 4, 2, 13, 52. 125, 25, 5, 2,000. 1,110, 1,000. It gives us that our A is 4, our B is negative 120, and our C is 900. And that's all they asked for. They didn't ask for the actual form. All right, almost there. So close. So V equals, if you want the formula, 4x cubed minus 120x squared plus 900. We're actually going to use that, though, to find C. We're going to use our formula, which I just told you about, 4x cubed minus 120x squared plus 900x, to find the volume of the rectangular prism. Now, what is the volume of a prism? Volume equals length times width times height, right? So our height is x, right? Our width, since this whole thing is 30, and each one of these is x, our width is 30 minus 2x. And whatever our width is, our length is as well. So this is also 30 minus 2x. So when we use our formula, length and width are equal, and our height is x. 30 minus 2x, all right? So the height is x, length and width are 30 minus 2x. 30 minus 2x times 30 minus 2x times x equals our volume. Now what you're going to do here is, you're going to distribute this 900 minus 60x minus 60x plus 4x squared times x. These combine. 900 minus 120x plus 4x squared times x. You're going to distribute this x. 900x minus 120x squared plus 4x cubed. All right? Got it? What do you notice? Anything yet? No? I noticed I wrote this wrong. This should say 900. Now, do you notice anything? This, let me rewrite this with my x cubed first. 4x cubed minus 120x squared plus 900x. It's the same as our model. So solving it this way gave us the same. So what values, so our model is the same as using the volume formula and expanding. Isn't that cool? Ah, it is. All right, so for what values of x can this model be correctly applied? X has some constraints, it has some parameters. X obviously can't be 0, so it has to be greater than 0, but x can only be, how big? Well, just think of it this way. If I made this, and it made it like this skinny, and it almost looked like this, what would my x's be? These x's have to be the same, so what could this be? Almost about what? About 15, right? Why did I say that? Because look what happens. If I pull an x out, I'm going to show you two things here. I just went back to this right here, and I solve. X equals 0. I can factor this. The factors of 225 that add up to 30 are 15 times 15 is 225. Negative 15 minus 15 is minus 30. I just factored this. X equals 0. X minus 15 equals 0. So x equals 15. But you may say, oh wait, you did that mathematically. How'd you get this 15? Well, if the whole thing is 30, what's half of 30? 15. So you can solve it that way as well. But the values is x has to be greater than 0, can't be 0, and it has to be less than 15. It can't be 15. All right, it'd probably be a lot less than that, but mathematically that's all we do. All right? And guess what? That concludes our review. So, very glad to be able to help you out with this. Concludes chapter 4. We're 4/9 of the way through this year. We're about a quarter of the way through the book, so we're making good progress. All right? We're going to keep this up, keep you guys doing good. You guys do good on this test. And by the end of the year, oh, get this off my picture. You guys will be masters of all the IB math tricks. All right, so until next time, glad I could help you.